In this video, I'll demonstrate how to use the dplyr library to load data frames as tibbles and how to create tibbles in the same way we would create traditional R data frames. Now I do assume that the dplyr library is already installed, either directly or through the tidyverse package. Now the dplyr library gives us an alternative data frame, which we call a tibble. This provides stricter checking and nicer formatting than traditional R data frames. So on line 1, I load the dplyr library, so I have library dplyr. On line 3, I take the head of the iris dataset to see what we're going to be working with. So in the console, we have printed the first 6 rows of the iris data frame. So it provides the sepal.length, sepal.width, petal.length, petal.width, and the species of various irises. So there are a bunch of iris measurements. To convert this from a data frame into a tibble, we use the as_tibble method provided by dplyr. So on line 4, I have iris_tbl, so that's going to be the name of our iris as a tibble, and we assign that to as_tibble with the argument iris. Now let's have a look at iris_tibble. So on line 5, I do head of iris_tbl. So in the console, it's printed with a little bit of extra information. So it has a tibble, which is 6 by 5, so 6 rows and 5 columns. It has the same headers, but it also includes some type information. So in the gray text, it has DBL for double, so the columns are double, 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 and FCT for factor, so the species is stored as a factor variable. On line 6, I call class of iris_tbl, and that shows the compatible classes. So tibbles are tbl_df and tbl, but it can also be a data.frame. So it is stored internally as a data.frame, and it can easily be coerced as a data frame. We can get the column names by calling call names of our iris_tbl. So many of the things we can do with a data.frame, we can do with a dplyr tibble. We also get this view function, view spelled with a capital V. So view of our tibble gives us a spreadsheet-like interface into exploring our tibble. So that's what gets loaded when we run view on a tibble. So I'll close our spreadsheet view and go back to the code. Now on line 10, I create a tibble from scratch called pineapples. Now in this case, I have pineapples is assigned to tibble, and then I declare the tibble, the country and the production values for this tibble. But if I replace tibble with data.frame, it would work interchangeably. So data.frame and tibble in many cases are interchangeable. But tibble does provide us that extra checking and the nicer formatting. So on line 10, I'll continue. Pineapples is assigned to tibble with country equal to the vector created by C of the values Costa Rica, Brazil, Philippines, Thailand, and Indonesia, and the production values, the vector 2.7, 2.5, 2.4, 2.2, and 1.8. So I'll create this pineapples tibble, and I'll output the contents, and it gives us in the output a tibble 5 by 2 with country and production columns. Country is a character column and production is a double, and then it has the values I initialized it with. Again, the structure function, the str function, works on a tibble just as it would a data frame. So on line 15, I call str of pineapples, and it gives me the same information as I would if it was just a plain data frame. We can index columns, so pineapples indexed at 1 gives us the first column, or we can index it by the column name. So pineapples indexed at the character string country gives us the first column just the same. We can index a single cell within our tibble. So on line 19, I have pineapples, and in square brackets 1, 1, which gives me the first row in the first column. So the result is Costa Rica. And we can coerce the pineapple tibble back into an R data frame by using as.data.frame. So on line 21, I do just that on our pineapple tibble. And I spelled it wrong. Pineapple is pineapples, plural. So I'll run line 21 again, and we get the result as a data frame. And that concludes this demonstration of creating dplyr tables. In this video, I'll demonstrate how to select subsets of data using dplyr tables. Now I do assume that the dplyr library is already installed either directly or through the tidyverse package. So on line 1, I can just load the dplyr library using library and in parentheses supply dplyr. And now I'm going to create a tibble called coffee. So I have my coffee variable on line 3 and I assign it to tibble. Now this is created much in the same way we create regular data frames in R. So we pass it some variables on line 4, country, which will be our first column, is equal to the vector defined by the function C with the character values Brazil, Vietnam, Indonesia, Colombia, and Ethiopia. Then on line 5, I have production equals the vector defined by the function C with 43.4, 24.0, 8.6, 7.6, and 6.0. On line 6, we have percent defined by the vector with the values 32.4, 17.9, 6.4, 5.7, and 4.5. And the last column will be called increasing, which I've defined on line 7, which is equal to the function C with the values false, true, true, false, true. So I'll run this line of code and create our tibble called coffee. In line 8, I just output the contents of coffee to the console, and we can inspect that we have a tibble that's 5 by 4, so 5 rows and 4 columns. The columns are country, production, percent, and increasing with the values that we set when we created it. So to select a subset using dplyr, we use its select method. So select comes from the dplyr library, and on line 10 I call select with its first argument as the tibble we're going to select from, and the subsequent arguments the columns that we'd like to select, in this case country and production. So when we select with those arguments, in the output we have printed a tibble that's 5 by 2, so 5 rows and 2 columns. So we just get the country and production columns, but we get every record from this tibble dataset. On line 12, I use a helper function called starts with. So we select, again from coffee, but instead of supplying a column, we supply a helper function starts underscore with and the character P. So this will select columns that start with a particular string, in this case, the character P. And when we run that line of code, we get our tibble that's 5 by 2, so 5 rows and 2 columns, and those columns are production and percent because those are the two that start with the character P. Now if we'd like to select a range of columns, we can use the colon syntax. So on line 13, I have select with coffee as the first argument, then the second argument is country colon percent. So if I run that line of code, we get country and percent and every column in between those two. In this case, country, production, and percent. So it selects a range of columns, but a range given by the name of the first column and the name of the last column in the range. And finally, we have a select function where we're going to exclude particular columns. So on line 14, I have select. The first argument is coffee. Then the second argument is negative increasing. So this means to exclude the increasing column from the select. And then the next argument is negative percent. So this means to exclude the percent column. So this will select from the coffee tibble, excluding increasing and excluding percent. So that gives us a tibble that's 5 by 2, so 5 rows and 2 columns, with country and production because we've excluded increasing and excluded percent from this select. And that concludes this demonstration of selecting subsets. In this video, I'll demonstrate how to filter tabular data using dplyr with a few of its common filtering functions. So on line 1, I load the dplyr library using library, and in parentheses I specify dplyr. On line 3, I'm going to create a tibble called coffee. Now I'm reusing this coffee example as seen in the video selecting subsets. So this is coffee production data for 5 of the largest coffee producers in the world. So I execute line 3 and create the tibble with our data set. And then on line 8, I type coffee so that we can see the contents of this tibble. So we get a tibble that's 5 by 4, so 5 rows and 4 columns, with country production percent and increasing columns for this coffee production data. Now let's suppose I'd like to filter out producers that produce more than 20 million tons of coffee per year. So on line 10, I have filter. So it's a filter function that comes from dplyr. The coffee, so I specify the tibble as the first argument to the filter function. And then I specify the column and then the expression. So production greater than 20. So when I execute line 10, we get the resulting tibble containing 2 records. So it has all of the columns, but only the rows where the production was greater than 20. So that's Brazil and Vietnam with production of 43.4 and 24 respectively. Now the increasing column is whether or not the production is increasing or decreasing. So if we'd like to filter out only the countries or only the records that have the increasing column set to true, we can do filter with the coffee tibble and then increasing the double equal sign true. So anywhere where increasing is true will be filtered out in this query. So in this case, we get 3 records, all 3 where the increasing column's value was set to true. Now on line 13, I have a function called sample_n. Now this works much better when you have a large data set where we want to pull a sample of that data set. So let's say we want a random sample of 3 records from a particular data set. Well, in this case, we take the sample_n, specify the data set, in this case our coffee tibble, and then the number of records we'd like to randomly sample. So when I execute line 13, we get 3 chosen at random. Now if I arrow back to line 13 and run that line of code again, we get a different result. So the first result of sample n gave us Colombia, Indonesia, and Ethiopia as the countries. And then in the second running of sample n, we got Vietnam, Indonesia, and Ethiopia. So each time you run sample n, it gives us a different result. Now the last filtering function I'm going to cover from the dplyr library is slice. So slice takes a subset of rows from our tibble. So on line 15, I have slice, I specify coffee, and then I specify the range 2:4. So this will return the records or the rows from 2 to 4. So 2, 3, and 4 will be returned. So when I execute that, I get Vietnam, Indonesia, and Colombia, but the first record, Brazil, and the last record, which was Ethiopia, are excluded from this result. And that concludes this demonstration of filtering tabular data using dplyr. In this video, I'll demonstrate how to perform multiple operations using the pipe operator. Now I do assume that the dplyr and tibble libraries are already installed either directly or through the tidyverse package. So on line 1, we can just call library dplyr, and on line 2, library tibble, to load those 2 libraries. Then on line 4, I create a tibble called cars, and I create this using the as_tibble method. And as an argument to this, I pass another method called rownames_to_column. So this function takes a data frame and converts its row names to actual columns. So I pass the empty cars to the rownames_to_column function, and then I set var equals car. So that will take the row names, create a column with them, and that column will be called car, because the empty cars data frame has the row names as the car names. So if I type in the console empty cars, you'll see all of the car names on the left-hand side, but there's no column heading because those are the row names. So when I execute line 4 and create the cars tibble, and on line 5 I call head with cars as its argument, we can see that we have a tibble now with a car heading with all of the car names under it. So we have our MT cars built-in data set from R converted into a tibble. Now let's look at the pipe character. So dplyr gives us a special operator, % greater than %, which passes function arguments to one of its methods. So dplyr gives us a special operator. It's designated % greater than %, and this passes function arguments to the method that comes after it. So on line 7, I have cars, and then I have % greater than %, so I have the dplyr pipe. And then on the next line, on line 8, I have the top underscore n function, which is a dplyr function, which usually takes a dplyr tibble or a data frame as its first argument, but since we've introduced it with the pipe operator, we ignore the first argument and just supply the n argument, so the number of rows, 10, and then the top based on the value, in this case mpg. So this top underscore n with 10, mpg will get the top 10 cars by their miles per gallon or their gas mileage. And then we end line 8 with another pipe operator, which means the next function is going to pass the result on to the next function as its argument. So on line 9 we have arrange, and then I just have to specify negative mpg. So I'm sorting in terms of miles per gallon in descending order. So I want the car with the highest miles per gallon to be shown first, or to be arranged first. And then I pipe that into another method, filter, for HP greater than 70. So I only want to include cars with horsepower greater than 70. So now I'll execute this command with all of the pipes, and then we get a tibble with 5 records. So we have the Lotus Europa with 30.4 miles per gallon, and the horsepower is indeed over 70, it's 113 in this case. The Porsche 914-2, which gets 26 miles per gallon with 91 horsepower, and then the Datsun, the Merc, and which is short for Mercedes, and the Toyota Corona. And that concludes this demonstration of piping data using dplyr. In this video, I'll demonstrate how to create new columns using dplyr's mutate method. So on line 1 of this example code, I start by including the dplyr library. So I have library and in parentheses dplyr. So we have the library loaded now. Then on line 3, I create a tibble called coldest. And I assign that to the tibble created with the variable place, which is equal to the vector created by the function c with the following character string values. So it has Plateau Antarctica, Amundsen Antarctica, North Ice Antarctica, Ice Mitte Greenland, and Resolute Canada. And line 6, I add to this tibble a temp underscore f column. So these are temperatures in Fahrenheit degrees. So that's set to the vector created by the function c with the values negative 70.1, negative 56.2, negative 22.0, negative 20.6, and negative 11.6. So we have some very cold places in this data set. So I'll add that to our workspace. And then on line 8, I output coldest to the console. So we have a 5x2 tibble, so 5 rows and 2 columns with place and temperatures in Fahrenheit. Now what I'd like to do is create a new column with the temperatures converted to Celsius. So on line 10, I create another tibble called coldest2, and I assign that to our tibble coldest, but it's piped into the mutate method. So mutate will compute a new column from an existing column. So I call the new column temp underscore c for temperature Celsius, and I set that equal to the temp underscore f subtract 32. So I surround that in parentheses, and then I divide it by 1.8. So that converts the temperature in Fahrenheit to Celsius, and it will create this new column. So I'll execute line 10, and then on line 11, I output coldest 2. And in the output, we now have a tibble that's 5x3. So it has the place, the temp underscore f, and the temp underscore c. So that's one of the ways we use our mutate method to create a new column that's a conversion of another column. But we're not limited to computing on a single column, we can actually create new columns out of multiple columns. So on line 13, I create a new tibble called EG, and that's assigned to the tibble with the variables val1, which has the values 10, 20, and 30, and val2, which has the values, the vector created by C, with 1.2, 1.5, and 0.9. So I'll execute line 13, and then on line 18, I create another new tibble called EG2, and that's assigned to the tibble EG piped into the mutate method that has the product of val1 and val2. So val1 star val2. So I'll create EG2 from line 18, and I'll output the contents on line 19. So EG2, which gets printed to the console. So we get a tibble that's 3 by 3 with the columns val1 and val2, and then the third column is val1 star val2. So if we don't specify a column name, it actually just includes the computation itself as the column name. And the results are the product of the first two columns. And that concludes this demonstration of mutating data with dplyr. In this video, I'll demonstrate how to summarize data using the dplyr summary functions. So on line 1 of this example code, I load library dplyr. And then I do library of tibble to load the tibble library. So the tibble library gives the row names to column function I'm going to use because I'm going to use the mtcars dataset, which has the car makes and models as the row names. So I want to convert those to columns. So on line 4, I create a new tibble called cars, and I assign that to the result of the as_tibble method of the row names to column method of mtcars, where I set the row name variable, the var equal to the string car. So I'll execute line 4, and then we'll check it using the head method. So head of cars gives us the first 6 rows of our cars tibble. So it has the car as the first column with the car makes and models underneath. And then it has all of the existing variables or existing columns that come with mtcars. Now on line 7, I'm going to run a summary method. So I take our variable cars, the tibble, I pipe that in using the %> symbol, so that's the dplyr pipe method. I call the summarize function, and then I create the data point avg_mpg. So this is average miles per gallon equals the mean of the mpg. So line 7 gives us a tibble, a 1x1 tibble with average_mpg and a single data point, 20.1. So that's the average of the cars in that data set. On line 9, I'm going to get a summary of the max miles per gallon, or the max mpg. So I take cars, I pipe it into summarize, and then I call it max_mpg equals the max mpg. So the max is a built-in function, and it's going to take the max of the miles per gallon. And the maximum value in the dataset is 33.9, which is what we get in the output. On line 10, I pipe cars into the top_n method. So this will give the actual record. So the first record, so top_n takes the number of records, so 1, and it's done by miles per gallon. So this will give me the record from the cars dataset of the vehicle that had the highest miles per gallon. And that was the Toyota Corolla with 33.9, which is what we get in the dataset. On line 12, I take our cars dataset and I pipe that into the count function. So this will count the unique values of a particular column. So cars, %> count, and then I specify CYL for cylinders. So this is the CYL column, and the result of line 12 gives us a tibble that's 3x2, so 3 rows and 2 columns, and the columns are CYL, and N standing for the number. So the first record gives us cylinders with 4. There's 11 cars in this data set that are 4-cylinder cars. There are 7 cars that are 6-cylinder cars, and there are 14 that are 8-cylinder cars. And that concludes this demonstration of summarizing data using the dplyr summary functions. In this video, I'll demonstrate how to use the dplyr join functions to combine data. So I start out on line 1 with library and dplyr in parentheses. So we load the dplyr library. And now I'm going to create a tibble called people. So people is assigned to the tibble defined by the ID, which is set equal to the vector with the function c with the values 1, 2, 3, 4, 5, and 7. And then on line 5, I have name equals the function c with the character strings Steve, Jane, Bob, Sally, Joe, and Alice. So I'll create our people object. And then on line 8, I create an object called I_color, which is assigned to the tibble. And on line 9, I define it by its ID. So ID equals the C function with 1, 2, 3, 4, 5, and 6. And then on line 10, I have color equals the C function to create a vector with blue, brown, green, blue, brown, green. So after I create those two tibbles, I can join them together. So on line 13, I perform a left join. So it's going to take the values from people and try to match them up with the values from iColor based on the ID. So the syntax is left_join. The first argument to this method is people. The second is I_color. And the third is by equals the string ID. So the result of this that gets printed to the console is a 6x3 tibble. So the columns are ID, name, and color. And then I get the values 1 Steve Blue, 2 Jane Brown, 3 Bob Green, 4 Sally Blue, 5 Joe Brown, and 7 Alice N.A. Now the ID 7 with the name Alice exists in the people tibble, but not in the iColor tibble. So it doesn't have anything to match up with. Now we're performing a left join, so people is the left table or tibble that's being included in the join. So it takes everything from people and matches it up with the iColor, and where there's no match, it puts an NA value in. Now the right join is similar, which I do on line 14. So I have right_join, and then I specify people, I_color by ID. So since iColor is the right side argument, it will do the same as the left join, but with taking everything from iColor instead of people. So we get another tibble that's 6 rows and 3 columns, the same columns, ID, name, and color, but we have all the colors in this case, but we're excluding one of the names. So in the results, we have 1 Steve Blue, 2 Jane Brown, 3 Bob Green, 4 Sally Blue, 5 Joe Brown, and 6 N.A. Green. So since there's an ID 6 in the iColor tibble, but not in the people tibble, it doesn't include it. So we just get an NA value for the last value. Now in line 15, I perform a full join. So full_join of people and iColor by ID again. And in this case, it has all of the rows from people, all of the iColors from iColor, but for ID 7, which is contained in the people tibble, we get Alice with an iColor of NA because there's no corresponding ID of 7 in iColor. And then on the last line, we have 6 NA Green because there's no ID 6 in the people table, but there's a 6 in iColor that's green, so it matches it up with the NA value. And then on line 16, we perform an inner join. So in this case, there'll be no NA values. So if a corresponding ID does not exist in the other table, then it doesn't get included. So executing this inner join of people and iColor by ID gives us a tibble of 5 values, 5 rows, and 3 columns. And it's just the IDs of 1 to 5. So the ID 6 that exists in iColor but not in people gets excluded. And the ID 7 that exists in people but not in iColor also gets excluded. But we get everything else. And that concludes this demonstration of the dplyr join function to combine data. In this video, I'll demonstrate how to use the group by method from the dplyr library. So I start in line 1 of my example code calling library with dplyr as its argument. So this will load the dplyr library so we can get access to its functions. The dataset I'm going to be working with in this example is the iris dataset. So on line 3, I call head of iris just to get a sense of what we're working with. So the iris dataset has the sepal length, sepal width, petal width, and species of 3 different species of iris. Now in the first 6 records, we only see the setosa species, but there are 2 others. On line 5, I'm going to get the structure of the iris dataset by calling the str method. So this gives us the full structure of the data frame. So there's 150 observations of 5 variables, and in the output we have the 5 variables, which I just mentioned on the previous example, and we have their types and some information about what they are. Now another way of doing this is provided by dplyr called the glimpse function. So it's an alternative to the structure function, so I'm going to execute it now. So glimpse of iris on line 6 gives us the same information, or very close to the same information, but it's in a little more condensed fashion. So it says observations, 150, variables 5. So it lists the information a little bit more compactly, and it gives us the types, the double factor. Now on line 8, we're going to use the group by method. So I have the data set, this data frame iris. I pipe it using the % greater than %, and I pipe that into the group underscore by method. And then I specify species. So it's going to group by the species. So there's 3 different species, and then I pipe them into the summarize function. So we're going to create a summary based on the petal length. So on line 9, I have summarize, and in parentheses, max underscore petal underscore length equals. So that defines a column name, and the value for that column is going to be based on the max petal dot length. And then I take that result, the summarized results, and I pipe it into the arrange method. So I call arrange on line 10, and then I arrange it by the negative max petal length. So this will put our summary in decreasing order. So I'll execute that line of code, and that returns a tibble that's 3 by 2, so 3 rows and 2 columns. First column being the species, and the second row being the max petal length. So we get the results of the Virginica, which has a max petal length of 6.9, the Versicolor with a max petal length of 5.1, and the Setosa with a max petal length of 1.9. And that concludes this demonstration of grouping using dplyr. In this exercise, you'll load a data frame into a dplyr tibble. Now, feel free to either use your own or use one of the built-in datasets for this exercise. Select a subset of columns, compute and append a column using mutate, filter a subset of rows meeting a particular criteria, use the summary function on the data, and arrange the data grouping by a particular categorical value. Now you can pause the video and perform the exercise, and when you've completed it, come back to the video to see what I did. Now here's how I carried out the exercise. So on line 1, I load the dplyr library, so I have library and in parentheses dplyr. Then on line 2, I have library tibble. On line 5, I load a data frame into a dplyr tibble. And in this case, I'm using the built-in mtcars dataset. But I'm loading it in the following way. So on line 5, I have cars is assigned to as underscore tibble, and then I call the function row names underscore 2 underscore column. I give it the mtcars dataset, and I set the row name equal to car. So var equals the car string. So I'll load this cars into our environment. And now I'm going to select a subset of columns, and I'm going to call that tibble created by the subset cars underscore subset. So on line 8, I have cars underscore subset is assigned to cars, piped into the select function with car, mpg, sil, hp, and disp as the columns I want to save. And now I'm going to compute and append a column using mutate. So what I'm going to do is I'm going to take the displacement column, so the disp column, which is the displacement of the engine, so the size of it, in cubic inches. And I want to convert that to liters. So on line 11, I take cars underscore subset, and I assign that to cars underscore subset piped into mutate, where I set liters equal to disp divided by 61.024 to convert the displacement from cubic inches to liters. And now I'm going to combine the last three items of the exercise into a single statement. So I'm going to filter a subset of rows, use a summary function, and arrange the data grouping by a particular categorical value. So on line 16, I take cars underscore subset, I specify the pipe character, then on line 17, I call the filter function with mpg greater than 14. So I only want to include cars that have greater than 14 miles per gallon of gas mileage, of miles per gallon. I pipe that into group by, so on line 18, I have group underscore by of cyl, CYL. So we're going to group by the cylinders. In this data set, the cylinders are 4, 6, or 8. And then I pipe that into summarize on line 19 with average or AVG underscore MPG equals the mean of MPG. And then finally, on line 20, I arrange by CYL, the cylinders. So that's the categorical value, which is either 4, 6, or 8. So I'll execute that last statement. And in the results, we get a tibble that's 3 rows and 2 columns with the number of cylinders and their average miles per gallon, but excluding any car that gets under 14 miles per gallon. So we have cars with 4 cylinders have an average of 26.7 from this data set. Cars with 6 cylinders have an average of 19.7 miles per gallon, and cars with 8 cylinders have an average miles per gallon of 16.1 from this particular data subset that we used. And that concludes this exercise on querying data with dplyr.